Welcome back to Tech Pulse, your go-to show for breaking down the latest breakthroughs in science and technology, making them not just digestible, but actually exciting. I'm Zaber.
And I'm Puck. Hey, before we dive in, don't forget to hit that subscribe button, drop a like, and maybe share this with a friend who's secretly obsessed with quantum computing but pretends it's too geeky.
Today's headline is huge. Canadian startup develops device that cuts quantum computer heat emissions by 10,000x.
Wait, did you just say 10,000 times less heat? That sounds insane. Let's slow down a bit, Zaper. What does that actually mean for quantum computers?
Great question, Pug. So first, a quick primer. Quantum computers aren't like your laptop or phone. They use qubits, basically quantum bits, to do computations. Qubits can exist in multiple states at once, which is why quantum computers have the potential to solve some problems exponentially faster than classical computers.
Okay. And these qubits are super sensitive, right? Like even a tiny bit of heat can mess with them?
Exactly. Most quantum computers need to operate near absolute zero. That's minus 459 degrees Fahrenheit, just to keep the qubits stable. Imagine your computer freezing, but like literally. Any extra heat can collapse those quantum states and ruin the calculations.
So normally they have these huge, complicated cooling systems.
Yep, and that's where Qubic Technologies comes in. Their breakthrough is called a cryogenic traveling wave parametric amplifier, or TWPA. Basically, it measures quantum states without generating all that extra heat. And the kicker, it reduces thermal output by a factor of 10,000, basically down to zero.
Wow. So instead of a giant fridge system, you might only need, what, like a little fridge?
Pretty much. Or at least a lot less cooling than we currently need. This could be a game changer for making quantum computers commercially viable.
Okay, but let's talk details. How did Qubic get here?
So the company based in Canada is currently prototyping this amplifier. They got 925,000 CAD from the Canadian government through programs like Innovation, Science, and Economic Development, and the Fabric program.
That's almost $1 million. Not bad for a little amplifier. And when do they plan to bring this to market?
The current plan is a 2026 release, so still a couple of years out, but in tech terms, that's right on the horizon.
And how does this fit into the bigger quantum scene? I mean, are we talking just a small tweak or a full-on industry shift?
Oh, it's a pretty big deal. Think of it like this. The quantum computing market is exploding. Global investments just passed $1 billion in 2025, and projections showed the market could hit 28 to 72 billion by 2035.
Whoa, that's like serious cash. And this kind of heat reduction actually makes it easier for more companies to jump in, right?
Exactly. Less heat means simpler systems, smaller costs, and faster deployment. Qubic's TWPA is a real infrastructure breakthrough, helping move quantum computers from labs into practical commercial use.
All right, for our listeners who aren't quantum physicists, quick TLDR, TWPA, cryogenic, qubits. Can we unpack that?
Sure. TWPA, traveling wave parametric amplifier, is basically a very precise measurement device that amplifies signals from qubits without heating them up. Cryogenic just means super cold, like freezer on steroids cold. And qubits, as we said, are the basic units of quantum computing. Unlike normal bits that are 0 or 1, qubits can be 0 and 1 at the same time, thanks to quantum superposition.
Got it. So the TWPA is like a super sensitive thermometer that doesn't warm up the thing it's measuring.
Exactly. Perfect analogy.
I also heard other companies are tackling heat issues too.
Yep. For example, Chalmers University developed a pulsed amplifier that cuts power consumption by 90%. And Amplitech Group has cryogenic amplifiers with insanely low noise, sub 0.1 decibels. And IBM is building a super fridge called GoldenEye to house million qubit machines.
Million qubits? That's a lot.
Yeah, it's mind-blowing. And companies like QET Sweden are already selling commercial TWPA products with 4 gigahertz bandwidth. So Qubic is joining a rapidly advancing field.
So this isn't just a small tech improvement. It's part of a bigger quantum arms race.
Exactly. And Qubic's device could remove one of the key scaling barriers, heat, making quantum computing more accessible for businesses and researchers alike.
So if this works as promised, what could we see in, say, 5 years?
Imagine cloud-based quantum computing that doesn't need massive cooling setups, cheaper quantum hardware, and faster commercial applications in things like drug discovery, finance, and cryptography. Oh, and shorter, cheaper prototypes for startups trying to test quantum algorithms.
So basically, the difference between quantum computers being a lab curiosity versus a practical tool.
Exactly. And it all hinges on innovations like this. Tiny, precise devices making huge leaps.
Also, it's kind of wild that something you might literally hold in your hand could make computers 10,000 times cooler.
Nice pun. Yes, exactly. Figuratively and literally cooler. So, to wrap up, Qubic Technologies' TWPA could dramatically cut heat in quantum computers by 10,000x, potentially accelerating the transition from lab research to real-world applications.
And this is just one of many exciting breakthroughs pushing quantum computing closer to everyday use without turning entire buildings into fridges.
That's all for today's episode of Tech Pulse. If you enjoyed this, hit like, drop a comment, and of course, subscribe so you never miss a moment of the future.
I'm Puck.
And I'm Zaper. Thanks for tuning in. See you next time on Tech Pulse.